Hi there, welcome to Mr Mickleburgh's Maths World. This is the way it is. Differentiation by rule, part 3. Today we're looking at differentiation of some awkward looking expressions. So number 1 here, it's not in calculus friendly form, is it? Y equals the square root of x. We need to convert this to index form. That's the first thing. If you don't know how to do that, I've done a little clip on that I've called indices and surds in calculus that you'll find elsewhere on YouTube. Alright, so y equals x to the power of a half. Now, I'm going to use this symbol for the derivative, y dash. We follow the same rules that we've been following all along. In other words, we bring the index out front, half x, and we reduce the index by 1, so it's negative a half. Now, it's considered bad manners in mathematics to write the answer in a form that's different to the form used in the question. In the question, we have used a surd, haven't we? So we've got to put this back into surd form. How do we do that? Well, we remember that, let me just get the pen on, right, y dash is going to equal a half. Let's keep that fraction a little bit separate from the rest of it. A negative sign in an index is saying we need 1 over the positive version. So, and then we remember that x to the power of a half is just the square root of x. So y dash is going to equal 1 over 2 square root x. That would be our final answer. Okay, let's have a look at problem 2. Y equals 1 over x. Well, that's not in what I'd call calculus friendly form either. So we would call this y equals x to the power of negative 1. Now we proceed to differentiate as usual. Therefore y dash is going to equal, bring out the index out front, negative 1, except we don't need the 1, do we? So we just write negative x, reduce that by 1, reduce the index by 1. And then, as I said before, we need to put this back, the answer back in a form similar to that used in the question. So y dash would equal negative 1 over x squared. Okay, let's have a look at this one. I think the way ahead here is to bring out the negative 3 and the 2. It might make it a bit easier to work with, like so. So fx equals negative 3 on 2 times 1 on the square root of x. Now, the other thing before we do the calculus is to convert the surd to index form. So we know that the square root of x is equal to x to the power of a half. Okay. Now what we can do is bring the x upstairs, and then we're ready to do the calculus. So fx equals negative 3 on 2 times x to the power of negative a half. Okay, so here we go with that calculus. So what we do here is, just to give us a bit of extra room, we say therefore f dash x now is equal to minus 3 on 2 times, okay, bring out the index, the negative a half, out to the front, rewrite the x and reduce the index by 1. Okay, so that's a little bit messy, the rest is tidying up. But that is the calculus done. Therefore, f dash x equals, okay, we've got negative 3 times negative 1, so that's 3, and 2 times 2 is 4. Times, what are we going to do with this? Well, we can put the x back downstairs by changing the sign of the index, and then because the question used surd form, our answer should use surd form as well. So that's our last step, which is to convert the x to the power of 3 on 2 to surd form. If you're not sure on how to do that, you can see the separate clip I did on indices, surds and calculus. Okay, now this one's very messy, and most of the problem is to do with algebra and not calculus. But let's make sure we understand what this is in fact saying firstly. Saying y is equal to negative x over, it's not 2 to the power of 3, which is what it might look like, but it's 2 times the cubed root of x to the power of 5. Okay? Alright, first step. Let's get rid of, let's get the negative out front and also the 2 out front. So that'll be negative a half times x on the cube root of x to the power of 5. Alright, next step would be to get rid of the third sign. So we would say, therefore, y, should be a therefore there as well, by the way, negative a half times x to the power of. Now I hope you remember how to convert these thirds to index form. X and the power is 5, the root is 3. Okay, let's make ourselves some extra room here. Now, we can get this upstairs by simply reversing the sign of the index. So let's do that. Y equals negative a half x over, times x to the power of negative 5 on 3. Okay? So what we're doing now is multiplying an x term by another x term, and when we do that, we simply add the indices. And there's an invisible 1 there, which is not so invisible now, is it? So what we're going to do is perform that multiplication. Sorry, that's y dash. No, it's not. It's still y, isn't it? So, we haven't done the calculus yet. So anyway, 1 plus negative 5 on 3. So that's like 3 on 3, take 5 on 3, isn't it? And it's going to be x to the negative 2 on 3. So now, at long last, we are ready to do the calculus. So we would say dy dx, or y dash, doesn't matter, equals negative a half times, bring out the index out front, negative 2/3, and reduce your index by 1. So negative 2/3 take 3/3 is going to be negative 5 on 3. So we're kind of back to here again, aren't we? And what does all that equal? Well, it equals negative 1 times negative 2 is 2, and 2 times 3 is 6, so 2 on 6 is 1/3, and x to the power of negative 5 on 3. Okay, let's make ourselves some extra room and get ready for the answer. So, we would now put the x term downstairs in the denominator. So this is going to look like dy dx equals 1/3, 1 over, you put a time sign there if you like, x to the power of 5 on 3. And then what you would do is put it back in third form, because that's the form the question was in. Dy dx is equal to 1/3 times 1 on. Okay, so the power of x is 5 and it is the cubed root. And finally, what you would do is just bring the fraction back into the expression and conclude that dy dx is equal to, now 1 times 1 is 1, so we write 1 on 3 cube root x to the power of 5, and that is our answer.